In this lecture, we will try and we will see how to solve for the utility function that is given to us as u is equal to x to the power 3 by 4, y to the power 1 by 4. This is the utility function that is given to me, and I have to find out or derive Marshallian demand function. So derive Marshallian demand function for this utility function. Let's try and see how will we solve this. I am going to do it in 2 steps. Step 1, find equilibrium condition. Step 2, substitute whatever equilibrium condition you will get. How do you get this equilibrium condition? You get this equilibrium condition by equating MRS to PX by PY. So you derive the equilibrium condition, and once you derive this, you substitute it in the budget line. And you find out X star, Y star. Now, one thing that we can do is this with this entire question. But what I'll do is I'll also progress one way ahead or one step ahead. And what I will do is I will also, first I will derive the Marshallian demand function. But what I'm also going to do here is I will ask you to find out the indirect utility function. So this is direct utility function. Okay. Direct utility function is any utility function which is directly in terms of good X and good Y. This is direct utility function. A direct utility function is directly in terms of good X and Y consumption. An indirect utility function is in terms of income and prices. So I'm going to ask you to find the indirect utility function. Let's see how we are going to go about it. So U is given as X to the power 3 by 4 and Y to the power 1 by 4. Step 1. Equilibrium condition is MRS is equal to PX by PY. MRS is actually found by saying MUX by MUY is equal to PX by PY. MUX is how utility changes when good X changes, how utility changes when good Y changes. This is equal to PX by PY. Now, how utility changes when good X changes is you differentiate the utility function with respect to X holding Y constant. So when we hold Y constant, what do we get? 3 by 4 X to the power 3 by 4 minus 1 into Y to the power 1 by 4. This is equal to 3 by 4 X to the power minus 1 by 4 Y to the power 1 by 4. This is equal to 3 by 4 Y by X to the power 1 by 4, because this is, in the negative power. Now, similarly, how utility changes when Y changes, that is going to be, you differentiate the function holding X constant. So this is, 1 by 4 Y to the power 1 by 4 minus 1 into X to the power 3 by 4. So this is going to be 1 by 4 Y to the power minus 3 by 4 into X to the power 3 by 4. So this will be 1 by 4 X by Y to the power 3 by 4. This is MUX, okay? This is MUY, okay? So what is going to be your MRS? MRS is going to be MUX by MUY. So this is going to be 3 by 4 y by x to the power 1 by 4, 1 by 4 x by y to the power 3 by 4. This is going to be 3 into, see, this is very simple to solve, okay? So this is y by x to the power 1 by 4. And this is, this is getting divided. So when I supposedly, it's very simple. See this, when I say that I'm dividing 1 by 1 by x, okay, this is nothing but x, right? So you just invert this thing, because this is saying 1 by x to the power minus 1. This is nothing but x to the power 1. Okay, so one way of kind of doing this thing whenever something comes in power is to revert it and solve it. So when I say x by y, it is getting divided by x by y to the power 3 by 4. This means it is getting multiplied by y by x to the power 3 by 4. Very simple maths, basic maths. So when power are same, when base is same, power gets added. So 1 by 4 plus 3 by 4 is 4 by 4, which is 1. So this is y by x. So this is my MRS XY. Now, you know what? I am going to later show you how to derive MRS XY. It is very simple. Whenever it is in the form of any equation, we'll do one question when I'm not going to take this as fractions, but I'm going to solve this general question, which is u is equal to x to the power a and y to the power b. I will solve this and I will derive MRS for this. So once I derive MRS for u is equal to x to the power a, y to the power b, you can just substitute a and b and get your MRS in any case. Okay. So I will do that. Don't worry. But for now, I have derived my MRS as MUX by MUY. Now at equilibrium, I know MRS is equal to PX by PY. So I know 3 by 4. Sorry, this is just 3. So 3 into y by x is equal to px by py. From here, just find out what's the value of y. So your y is going to be px by py into x by 3. This is the value of y. So I have done step 1 completely. Step 1 was to go ahead, find the equilibrium condition, and from here derive y in terms of x. Always. By the way, I'm doing all this. These steps are only possible if it is a differentiable function, okay? A min function, a max function, substitute goods function, they're non-differentiable. So, you're not, substitute function definitely is differentiable, but we don't use this method for reasons that we have discussed as part of our substitute goods class. But otherwise, just understand that these 2 steps that I follow to derive the Marshallian demand function only holds true for your Cobb-Douglas function or well-defined preferences, and I can also use them for quasi-linear preferences, something that I will again show you. So once I've gone ahead and I have derived my y, I'm going to put this in the budget line. So my budget line is px into x plus py into y is equal to m. So I get px into x plus py into px by py into x by 3, I'm just substituting y here, is equal to m. So I'm going to cancel out py and I'm going to get 3px by 3 plus xpx is equal to m, or I'm going to get x is equal to 3 by 4 m by px. This is my x star. Okay. Just notice that this x star is actually a upon a plus b. Just notice, into m by px. So what was your a? Your a was 3 by 4. What was your b? B was 1 by 4. So ideally 3 by 4 upon 3 by 4 plus 1 by 4, that is nothing but 3 by 1. 3 by 4 by 1, which is nothing but 3 by 4, right? So, this is just a passing note. You can go ahead and solve the question which talks about, which is of this form. X to the power a, y to the power b. Try and maximize this utility function. You will see what x star comes out to be, what y star comes out to be. You will be able to derive the general formula of x star and y star. So just try this, okay? Now, for now, I have derived my x star. I'm going to derive y star. So I'm going to put, for y star, I'm going to put it back in this equation. And my equation is px by py into x by 3. So this will be px by py. What is my x? X is 3 by 4 into m by px by 3. So if I solve for this, I am going to get 1 by 4 m by py, which is nothing but b upon a plus b into m by py. Now, once you have solved for x star and y star, what is my x star now? X star is 3 by 4 m by px. What is my y star? Y star is 1 by 4 m by py. What was my utility function? X to the power 3 by 4, y to the power 1 by 4. Instead of x, I'm going to put 3 by 4 into m by px to the power 3 by 4. Instead of y, I'm going to put 1 by 4 into m by py to the power 1 by 4. Now, this is important. Notice that after putting the optimal value of x and y, once I put down the optimal values of, x star and y star in my utility function, the utility function that I have derived is a function of income and prices. It's no more a function of my consumption of good x and y. It is a function of my income and prices. This is the maximum utility that I derive given my income and the market prices. This is the maximum utility I can actually attain. This utility that you derive in terms of income and prices is known as indirect utility function. So indirect utility function is a utility function which is in terms of income and prices. And direct utility function is a function which is in terms of x's and y's. So we started with a direct utility function. From direct utility function, we went ahead and we derived the Marshallian demand functions of x and y. This is my Marshallian demand function. And from Marshallian demand function, we went ahead and we derived the indirect utility function. Okay, thank you.